Screencast assignment number 1. The table of contents. An entity is a person, a place, an object, an event, or a concept in the user environment about which the organization wishes to maintain data. Thus, an entity has a noun name. Some examples of each of these kinds of entities are shown below. Customer and order are entities in the diagram on the right. An entity type is a collection of entities that share common properties or characteristics. We use capital letters for the names of entity types, such as employee on this diagram. In an ER diagram, the entity name is placed inside the box in representing the entity type. Now, an entity instance is a single occurrence of an entity type. An entity type is described just once, whereas many instances of the entity type may be represented by data stored in the database. For example, there is one employee entity type in most organizations, but there may be hundreds or even thousands of instances of this entity type stored in the database. A weak entity would be this dependent right here, because it cannot exist on its own. In fact, it doesn't have a primary key. It has a partial identifier because it must always be linked to employee, which is the strong entity. An attribute is a property or characteristic of an entity or a relationship type that is of interest to an organization. For example, automobile is an entity type and the attributes is vehicle ID, color, weight, horsepower. A required attribute would be like home address, because each student must live somewhere and he must have an address to associate it with. Now, optional attribute would be major, because not every student is decided on what major they're going to pursue. Most of them are undecided, and thus it shouldn't be required. It should be just an optional attribute. A composite attribute would be employee address. There are many more composite attributes, but in this example, employee address can be broken into different more attributes, such as street address, city, state, postal code, apartment number, and etc. Now, multi-valued attributes would be like skill, because let's say skill in programming, you could have Java, C++, C#, COBOL, Perl, and many more. Now, for derived attributes, the system will derive a value based on certain input, like date employed and today's date can show years employed by just subtracting and how many years the employee has been employed. Now, for identifier attribute, it's pretty much the primary key. They're used interchangeably. Same thing. Student ID or let's say social security. It's a really good identifier because it can directly link to just one individual. Now, business rules. It's a really simple topic. It's pretty much a two-way street, and it goes something like this. One author must write at least one book and can write many books. At least one book because there's one line, and many books because there's 3 lines. Now, this is cardinality. I'll explain it later. Just giving you a brief overview. And So that's one way, and the other way, one book must belong to exactly one author. The two lines right here. Now this is a relationship type. Rights. To continue relationship type, it's a meaningful association between entity types, such as completes. Chen completes C++, Chen completes Java. See, Chen has two instances. Or let's go with Gosling. Gosling completes Java. Gosling completes structured query language. Two instances. Now in total, it will be 10 instances. Degree of relationship. There are 3 different degrees of relationship in database. There's unary relationship, which is just relationship between instances of one single entity type. There's binary relationship, degree number 2, a relationship between the instances of 2 entity types. And ternary relationship, degree number 3, a simultaneous relationship among the instances of 3 entity types. Cardinality constraints. In this diagram, we show constraints by circle, 1 line, 2 lines, and 3 lines. Let me show you what this means using the business rule. A person owns 0 or 1 byte. So minimum 0, maximum 1 byte. Mandatory 1. Let's do this. One team is led by only one leader. We use the only one with 2 lines. Now, optional many. Student registers for 0 to many courses. So 0 would be the minimum cardinality, and many would be the maximum cardinality. Now to go back up to team and leader, minimum and maximum are both 1. Now for the last one, course. Okay, so one course uses at least one textbook and can use many textbooks. So mandatory many. Minimum cardinality is 1 and maximum is many. Associative entity is used to break many-to-many relationships. We do not like to use many-to-many relationships in database design. So we use certificate to break many-to-many relationships into two-to-many. Let me rephrase it. So one many-to-many relationship is broken into 2 one-to-many relationships. There's 1-to-many, and then there's 1-to-many. And we could achieve this by having certificate number. Thank you.